And let's now run the video. And as you see, we have 468 facial landmarks in real time. Hi there, my name is Sergio and I help companies, students and freelancers to easily and efficiently apply visual recognition to their projects. We're going to see right now how to find facial landmarks points on the face. We can get, using the Mediapipe library, up to 468 facial landmarks. I saw that there is a good Python API on the Mediapipe website, only I don't like the implementation that they do with Python, so it's somehow hard to extract the information that you need. So in this video, we're going to make this as simple as possible so that we can get exactly each coordinate with the point X and Y of the face so that we can do whatever we want. We will do this first on an image, and then from the image we move to the video. So let's start. In order to start, you need to make sure that you have two libraries. One is Opencv, Python, and the second one is Mediapipe. If you don't have them, you can install with two simple commands. First one, pip install Opencv Python to install Opencv, and then pip install Mediapipe to install Mediapipe. Once you have these libraries, you are ready to go. Now we're going to, first of all, load an image. So I have an image which is person.jpg, which I have on the same folder with facial landmarks. I suggest you use your own image, or if you want my image, you can download source code, image and video on the link below in the description. We're going to import cv2, then we import Mediapipe as MP. Now we load the image. The image is cv2.imread, and here we need to put the path of the image, person.jpg. How do we make sure that we are loading correctly the image? There is no better way than to show the image. So if we see the image, it means that we are loading it correctly. cv2.imshow. Here we can type the name of the window, you can call this image, and then what do we want to display? We want to display this image that we loaded before. And then we need a wait key event to keep the image on hold until we press some key. So cv2.wait key 0. And now we can run this one. And this is the image that we see. Once we have the image, we can move further. So the first step is done, getting the image. Now we need to, using the Mediapipe library, get the landmark's position. First of all, we need to initialize this, because Mediapipe is a big library which has a lot of functionalities. It has face tracking, it has also body pose estimations and other things. So we need to select the one that we need, and we need the facial landmarks. So to do that, we need to load face mesh. To load face mesh, we do first of all mp_face mesh, and we take this one from mp.solutions and you can see here face mesh. This is where is the location of face mesh on the library, but it's not done everything yet. We need a second line to load the object, so we will create a face mesh object which will do the detection. And so we can call this face mesh equals mp face mesh dot, you can guess, face mesh. And well, that's a big part of the work is done. Now the next step will be, now that we have the face mesh, which is the library which can process the image, somehow we need to give the image to this library to say, okay, now you can get the landmarks points from this image. So we have here the image. So after we load the image, we're going to process this image. So the result will be face mesh dot process, and we are going to process what? We're going to process image. Let's now run this one. Okay, it's good we don't get any errors, so it means that at least we're loading the library correctly. Of course, we don't see anything yet because I am not displaying anything. So what I want to do right now is show you something. Here we are processing the image, but this is not enough because there is one thing that you need to know about Opencv and face mesh and Mediapipe in general. Mediapipe processes the image using the RGB format. It means that the image has 3 channels. The first one is the red, the second the green, and the third the blue. While Opencv, in comparison with this and other libraries, processes the images in the format BGR. So it means that the blue is is the first one, so we have blue, green, and red. To make things simple, we need to change the image format. So the image will be, let's say, RGB image equals cv2.cvt color to convert the color. And we want to convert what? We want to convert image. And then cv2.color underscore, what do we want to convert? We want to convert the BGR format to the RGB format. And so now we will have RGB image. To give you an idea that we exchange the color, I'm going to show how this will look if we show RGB on Opencv. We have image. Instead of image, let's create a new one, which we will show RGB image. Here we inverted the color, the blue with the red. And of course, we don't need to show this one. It looks like the Avatar, the movie. I don't know if you remember, but it's looked like the same color. Anyway. Now, so we need to process the results. Facial landmarks from the RGB image. RGB image. Okay. Now, if we print result, well, we see Mediapipe Python solutions and blah, blah, blah. This is one of the things that makes Mediapipe face mesh hard to extract the information, because there is not much here to work with. Like other libraries, you will have right away the coordinates. Here we don't have that. So in order to access the coordinates, we need to make a few steps. First of all, we're going to loop through for facial landmarks in results dot facial. I don't remember this exact line. Let me check. Multi-face landmarks. Okay, multi-face landmarks. Yeah, I think I'm getting this correctly. Okay. Now, to make sure that we're extracting something correctly, we're going to print facial landmarks. Let's now run this one. And somehow we accessed some values. And as you see here, we have different coordinates with x, y, z, x, y, z. And these are all different points of the face. It's nice that we see them, but it's not yet enough to extract them. To extract them, we have 468 points. We will start extracting only a single point. So let's extract p.1 equals facial landmarks dot landmark. And now we take the point index 0. Let's print pt1. we have x, y, and z. Now that we have x, y, and z, we can extract them even more, because here we have point 1, we have all this information. So let's do x. Of course, we need just for this simple task, we need only x and y. So we need the x point, x pt1 dot x, y equals pt1 dot y. And now let's print them. Let's print x and y, x and y. And let's see what we get. So we have x 0.6 and so on, and y 0.3 and so on. This is another thing that makes Mediapipe hard to implement somehow with Opencv and to get the information right away, because when we work with coordinates, we should have the points, integer points of 1, 2, 3, and so on, so that we have the coordinates to put wherever we want on the image. Instead, here we have 0.6. What does this mean? That on this image, the x position is 0.6 of the image. So it means that if the width of the image is 1, on position 0.6, so around 60% of the image, we have the x position. So if we start from here to here, 60% will be somewhere around here. And it makes sense because the point is on the face. And the same is for the y. So this means that we need to convert these values into position on coordinates. How do we do that? Well, first of all, we need to know how big is the picture. So we go on image. On image, we can take the information of the image. We can take the height, and we can take the width. And then we can take the, here I put underscore because we don't need the channel, so we need only height and width, and it's image.shape. Now, what is the height and width? Let's print them. Print height, width, and we have height and width. So we have height is 853 and width is 1280. This means that to get the x position, we need to multiply each x with the width. So this will be 0.6 multiplied with 1280 and 0.3 multiplied with 853. And so let's do that. So we have x is 0.1 multiply x multiply with the width of the image, and then this multiply with the height. Is this enough? Probably not. Let me show something else and we're almost done. Now we get point x 794.94, point y 2059.42. What can you see wrong right here? We cannot have coordinates with the comma like float. Our coordinates is either 1 or either 2. It cannot be 1 point something. So we need to convert this to int, and we have 794 and 2059. This means that we can show this one. cv2.circle. So we're going to draw a circle right now on that specific point. Circle on, where do we want to draw the circle? We want to draw the circle on image. Now, when we draw a circle, we need a few parameters. So first one is, where do we want to draw the circle? The second one is the x and the y position where we want to draw the circle. Then how big is the circle? So we need to define a radius, and we're going to make these 3 pixels white. And then the color, let's make this 100 of blue, 100 of green, and 0 of red. And let's now run this one. Probably you can see it, I can see it, it's here we see the circle, a really small circle on the ellipse. What I can do to make this more visible, we can fill the circle. So -1 to fill the circle with the color. So we can put this at the end of CV2 circle. And now this will be probably more visible to you. Let's make 5 or 7 pixels, so a huge circle on the lip. And that's what you see. Now, you might be wondering, okay, that's one facial landmark. How can we access all the other facial landmarks? Well, it's really simple, because we can just change we can just change here the index. So instead of 1, we can access, instead of 0, we can access 1. Instead of the lip, now we have the facial landmark position. 1 is the nose, and we have many others of them. We can access, let's say, 50, and so on. We have 468 points. It wouldn't make any sense to just write these things 468 times. So what we can do is make a new loop for I in range 0 to 467 or 68. And then with this loop, we're putting the same function 468 times. Why I don't see this one? Well, in theory this makes sense, but I still see only 1 point. Okay, I see only 1 point because we need to draw the circle each time we get the point. If we don't draw the circle, why are we getting the point? Okay. And here are all the facial landmarks points. There are so many, so let's maybe make this smaller, only 2 pixels, so this will make sense. Okay, here is how you get all the points. If you want to know the position of each single point, you can put a text on the position, so you have exactly cv2.put text. Where do we want to put the text on the image? I cannot talk today for some reason. Put text on image. I'm going to do this quickly, X and Y. Okay, what text do we want to display? We want to display the string of I. So I'm doing this so that you can see what index number is each single point, in case you need only a few points and not all of them. We put this on X and Y. 0 is the font, 1 is the scale. And then the color, let's make this one black, 0, 0, 0. And if I run this, well, there are so many numbers that we cannot see them, but I believe that you get the point of what was my goal. Maybe you can do them with a few points and just check them over time. So to check the position of these points, so point 10, 9, 8, and so on. Now, I don't want to waste time on these small things. Instead, let's move to the second step, which is how do we work with videos? And to work with videos, it's really simple. So first of all, let me save this code. Let me create a new one. New Python file, facial landmarks video. Okay, I will put this code, and I'm going to change this code to make this work with a video. And it's really simple. Working with a video is pretty much as working with images, but instead of having only one image, we have a lot of images one after another. So we have a lot of frames. And the difference is that, first of all, we load the camera. Cap equals cv2.video capture 0. Okay, but I'm using the webcam, so instead of 0, if you want to use the webcam, you put 0. If you want to load a video, you put the video path. So I have this video, which is video.mp4. So original title, video.mp4. And then instead of loading the image, we're going to get the frame. So frame equals cap.read. And then also we have ret frame. I'm going to call this image so that I don't have to change anything, but it's a frame image. Okay. And I want to see if everything is as it's supposed to be. Let me run this one. Okay, it's working, but what you see, we're only getting one frame. So we need to change something else. So this is a video, but we're getting only a frame. Here we're loading the video. Now, how do we get multiple frames? We're going to put all this code into a while loop. While true. And then all of this. We put everything inside the while loop. Now let's run this one. Now you see we're still getting one frame, because when ending the while loop, we need to change the Opencv wait key function. So instead of wait key 0, we can put wait key 1. Wait key 0 is freezing the frame. Wait key 1 is just waiting 1 millisecond and going to the next frame. And of course, here is from 0 to 468. So let's keep this one clean and let's now run the video. And as you see, we have 468 facial landmarks in real time. And the results, it's great. They work really well. They're really precise. Now I'm going to conclude this one with one thing. What you see now, we're getting an error on line 13. It means non-type has a non-attribute shape. We're going to get this error because at some point the video finishes. So when a video finishes, there are not more frames to show. When there are not more frames, instead of having image, we have none. So we have an empty file. So what we have to do, we say if, okay, the image will be none and ret will say false, there are no more frames. So if ret is false, let's say it's not true, then we break the loop. It means that we end the video. And if we run this, we're going to get this one. And I hope this was clear regarding the purpose that I had to make face mesh as simple as possible to follow. I think I will keep uploading other things, other functionalities about the Mediapipe library, because it's a really powerful library and I cannot miss this opportunity. We cannot miss this opportunity. This is all for now and see you on the next video.